Hello everyone, this is Dr. G. Anita Hebsiba, Department of Chemistry, Dr. S.L.S. Rajaratnam College of Arts and Science, Coimbatore. In this video, we are going to study about a very novel dyeing technique which is called a salt-free dyeing of reactive dyes. We very well know in the conventional process of dyeing with reactive dyes, we require sodium chloride as the exhausting agent and sodium carbonate, that is sodium carbonate mild alkali, as an fixing agent. So they just increase the salt load of the dye liquor. So cellulosic fabric dyed with reactive dyes require large amount of salt which pollutes fresh water. Due to the hydrolysis of the dyeing effluent consists of large amount of hydrolyzed dye and it requires high volume of water to remove the hydrolyzed dye in washing process. Salt makes the dye bath electronegative and makes the fibers more electrochemically responsive to the dye molecules. That's why salt is required for extraction. The salt has a very high, stronger magnetic attraction to the water, and so the salt molecules hold hands with the water molecules, forcing the dye to go over to the fabric molecules where it can chemically react if the bath is alkali and from the soda ash. Reactive dyeing of cotton fabric typically requires a high concentration of salt or exhausting agent. However, only 65 to 70% of the dyes are exhausted. The remaining dyes are removed as color effluent. So treating the color effluent before discharging, again it is costly. So salt is also overloaded and there is also unused dye in the dye bath. So everything costs for the effluent discharge. So salt-free dyeing method. There are many methods applicable. First one is cationization. Cationizing the cotton fabric can eliminate the need for salt in the reactive dyeing process. Cationized fabric develops ionic bonds in addition to covalent bonds, which can improve the rubbing fastness of the fabric too. Liposomes. Encapsulating reactive dyes in liposomes can improve the level dyeing effect of reactive dyes. Liposomes can also reduce environmental pollution caused by traditional dyeing promoters. Acid fixing reactive dyes. These dyes contain phosphoric acid, carboxylic acid reactive groups which can reduce the salt requirement. So our main aim is to reduce the salt requirement and improving the dyeing efficiency. Salt substitutes. Alkali, earth, metal, organic complex compositions such as a mixture of magnesium acetate, magnesium citrate, magnesium polyacrylate can be used as salt substitutes. Cotton fabric were dyed with reactive dyes using conventional method, and then fabric is treated with polyvinylamine chloride. Pre-treated samples were dyed without using salt as an electrolyte. It was found that pre-treatment of cotton fabrics with polyvinylamine chloride increases the dye uptake and shows good washing fastness and wrapping fastness too. There was a slight increase in the crease recovery angle and flexural rigidity in pre-treated sample. It is considered that polyvinylamine chloride is found to be effective for pre-treatment in salt-free dyeing of cotton fabrics. It has been also found that the pre-treatment of cotton before dyeing can offer a simple and effective method of improving a dye fiber affinity, avoiding the need for salt as electrolyte in the dye bath. Non-reactive pre-treatments, including some polymers, can be used as fixing agents so that they uh, just increase the dye uptake. The pre-treatment of cotton fabric with polyacrylamide demonstrates the introduction of functional amino groups which increases the substantivity and also the reactivity of cotton. The cationic charged amino groups may be involved in the absorption of anionic chromophore of reactive dyes. The improved dyeability is populated, which also tend to be the presence of amide group available from the polyacrylamide, which again tend to improve the reactivity of the cellulosic fat substrate. However, high temperatures are generally recommended for dispersed dyes for fabrics to obtain penetration and fixation.